Hey, what's up, Logic fans? Welcome to our second video on propositional syntax. This is section 3.2. We're going to keep going over some rules of inference. We're just going to keep introducing these syntactic rules. And today we're going to be covering the rules of inference for the material conditional or the arrow. Let's rock. Alright, so I want to start off this video talking about the rules that we introduced last time, and those are the rules of inference for and or. And so we talked about simp, conj, disjunctive syllogism, add, and idempotence. I'm going to be taking these for granted now, and the problems you encounter as you progress through the text get a little bit harder in the sense that we're going to introduce some new rules today, but we're already taking for granted these ones, so you might have to apply these ones on a given problem as well as the ones we're introducing today, okay? And it builds sort of systematically that way so that you get lots of practice with all of them. So simp, conj, ds, add, and idempotent. If you need to review those, check out the videos on 3.1. Today we're doing Modus Ponens, Modus Tollens, Hypothetical Syllogism, and Constructive Dilemma. And again, these are rules of inference where the main connective is the arrow, okay? So let's jump straight into Modus Ponens. Okay, so here's how we will articulate Modus Ponens, also abbreviated MP, okay? And Modus Ponens is Latin for affirming the consequent, and it is historically one of the more important rules of inference in philosophy, okay? So, and mathematics as well. So let's take a look at the form of this type of argument, okay? You've got if P then Q and P. So Modus Ponens affirming the antecedent. So here's the antecedent. It's affirmed in the second premise, okay? And if you've got a conditional and you've got the antecedent, you can write down the consequent, okay, by virtue of Modus Ponens. So it's the Modus Ponens licenses this type of inference, right? And this is the type of thing you do all the time. So in ordinary English, if we said something like, oh, I don't know, if it's raining, then it's wet. It's raining, therefore it's wet, okay? So yeah, this is a very, very common rule of inference, and it's also very common to do one that's noticed as Modus Tollens. So let me write that on the board for you, and that's going to be abbreviated MT, okay? And it has a very similar structure, so let me show it for you. Start off with a conditional, and instead of affirming the antecedent in the second premise, you deny the consequent. So if P then Q, not Q, therefore not P follows. So if it's raining, then it's not wet, therefore it's not raining, okay? And that's Modus Tollens. So these have so you can either affirm the antecedent or deny the consequent. And that's what the rules Modus Ponens and Modus Tollens allow. So let's practice these two, Modus Ponens and Modus Tollens, MP and MT, with an example. So show this argument syntactically valid here. So you're given these four strings, okay? These are all premises, all right? This is a premise, right? And they're all premises. Boom, boom, boom. And so you're given these four strings to work with, and you have to use all of our rules, including probably Modus Ponens and Modus Tollens, in order to move from these strings to this string. Pause now and give that a try. Okay, so I'm going to give you a bit of a hint here, all right? And these are your premises all laid out, all four of them. Okay, so I'm getting you started here, and then remember you're trying to get to this thing. So, you want to start by asking yourself, what do some of your premises have in common? All right, and can those commonalities be exploited by one of our rules, such as Modus Ponens or Modus Tollens? See if you can finish from here. Okay, so what's really kind of cool here is that clearly 1 and 3 have something in common, right? This has not be in the consequent, and we have the negation of that here, which is perfect for Modus Tollens, right? Which wants you to have the negation of the consequent. So notice that in this particular case, Q is not B, and the negation of that is not B, which is what we have in line 3. So combining lines 1 and line 3 with Modus Tollens, what do we get out of that? We get not P. Well, P was just A in this case, and so we get the negation of that, which is not A. Okay, and that's how Modus Tollens works in this particular situation. Now, if this had been negated, if this had a negation on it, okay, then we would have had to have conclude not A by Modus Tollens, okay? But this is how it works, all right? So that gave us not A, and then we also noticed that we had something in common between lines 2 and 4, and in particular, we had the antecedent affirmed in line 4 from the conditional in line 2, which is a perfect setup for Modus Ponens with a P. All right, and Modus Ponens with a P gives you the consequent as is, making no other changes. And so that's what we have here in 6. And you can see everything explicitly laid out, and we were supposed to get not A and E. And so looking at what we're supposed to get from there, we just realized we could use one of our older rules from last time to conjoin these two together to build this construction, okay? And that's QED, all right? So that's a good introduction to Modus Ponens and Modus Tollens. But let me test you on Modus Ponens and Modus Tollens a little bit more. So let's see how you do with this. So your job here is you've got these two, and it's either going to be Modus Tollens or Modus Ponens. You have to tell me which one and what does it yield. So what do I get by application of Modus Tollens or Modus Ponens in this particular case? What do I get? Okay, and which one is it? Is it Modus Tollens or Modus Tollens that can be used here? Pause now. Okay, so in this particular case, the answer is Modus Tollens. Okay, so the answer is Modus Tollens here. And this is what it yields. It yields the negation of the antecedent. Notice the entire antecedent is this whole thing. And so if you have if P then Q, where P in this case is this whole thing, and you have the negation of the consequent, this is the negation of the consequent, which is this whole thing, then you get as an answer the negation of the antecedent, which is here. So this is a Modus Tollens case. Let's try another. Okay, so I'm switching things up a little bit here. I'm giving you the premise and part of the conclusion. What I want you to tell me is which rule was used. Was this Modus Tollens or Modus Ponens, and what was needed in line 2 in order to deliver this particular conclusion? Okay, so fill in line 2 and give me the rationale, Modus Ponens or Modus Tollens in this case. Pause now. Okay, hopefully you've had a chance to pause and think on this, but this was Modus Ponens on 1 and 2, and what you had to have was the whole antecedent, which in this particular case is this. Okay, so this is what it would have looked like for an application of Modus Ponens. I'll take this out here so it confuses you less, but that's what the argument would have to look like. All right, one more and we'll move on to another rule. So is this here now, changed it a little bit, is this a setup for Modus Ponens or Modus Tollens, and what does it yield? Pause now. Okay, so hopefully you've had a chance to think on it. This is a Modus Tollens setup. Okay, so we know it's going to be Modus Tollens on 1 and 2, but the big question is okay, what does Modus Tollens in this case yield? Pause now if you haven't had a chance to figure it out, okay? But the answer is that it yields the negation of the antecedent, which in this particular case looks like this, okay? So that is it. Now, a lot of people will say, oh, I got this by Modus Tollens on 1 and 2. That's incorrect technically, okay? We're going to have a way to get rid of the pesky negation symbols later. Strict MIT application of the rule of inference Modus Tollens requires this to get outputted. Remember, this is syntax. It's all about rule following, and it's completely uninterpreted random strings of symbols, okay? And this is what correct application of Modus Tollens yields in this particular case. Okay, I think you've got a pretty good feel for Modus Ponens and Modus Tollens now. So let's move on to another rule of inference for the arrow besides those two. All right, so let's move on to hypothetical syllogism, and we abbreviate this one HS, okay? And once again, if you have two conditionals, okay, so if you have, in this case, you're inferring a line from two other lines jointly, in this case, two conditionals. And it's a fairly natural thing. So, I mean, it says if this first thing is true, then this second thing is true. And if this second thing is true, this third thing is true. Therefore, if the first thing is true, the third thing is true. In other words, like, you know, if P is inside of Q and Q is inside of R, then P is inside of R, right? So it's fairly easy to remember that way. So let's look at an example of it in action. So in this example, you've got two premises and a conclusion that you're supposed to derive, and you may need to use hypothetical syllogism in order to move from these strings to this string. So pause now and give this one a shot. Okay, so here's a hint. This is all set up for you, all right? So you got your premises, and remember the conclusion you're trying to get. Let me put that on the board. You're trying to get from these two premises to this conclusion, okay? Pause now. Okay, so hopefully you've had a chance to pause this and work it out, but it's not that bad, all right? So the key feature to this particular problem that I wanted you to see and note, okay, was that in this case, P is this big thing here, and Q is this big thing here. So notice you've got Q here again, and then this whole thing, A and not B, is P, and not D is R. So P holds in the antecedent, and then the J or R, Q term drops out, and we're left with the R term, not D. So now we've got this new conditional here ready to go, okay? All right, so that's a really interesting sort of application of hypothetical syllogism, and those are the kinds of things you need to look for when you're investigating it. Okay, let's look at another rule. So our last rule for the day, and this will eventually spill into another video here so we can discuss it thoroughly. This last rule is known as Constructive Dilemma, abbreviated CD, okay? And it's our only rule that involves, you know, you have to have three strings in order to apply it. And the first one is a disjunction, but the other two are conditionals, okay? So let's go through this together and see if you can't sort of intuitively appreciate that it is a valid rule, okay? And you can run it through a truth table to verify it, okay? But first premise says either this first thing is true or this second thing is true. If the first thing is true, this thing holds. If the second thing is true, this thing holds. So either this thing or this thing holds, okay? And that's constructive dilemma, right? Maybe both of them are holding because both P and Q are true, but given that at least one of them is true and each of them has these implications, at least one of these implications has to be true. So what I want to do now is I'm going to spill us into a second video where we can discuss the constructive dilemma in a little more detail. So check for video 3.2b. See you there.